Hello. Today I will be sharing with you the results obtained from the Lab 2 for Physics 2211 on motion of a falling object. So, what was the main objective of this experiment? We observed the motion of an object dropped from rest. We compared the motion results analyzed in the tracker software with the computational model created through GlowScript, and we also computed the net force with and without the drag force, which we can consider air resistance as our drag force for this experiment. You can see in the picture, the object used was a small basketball, which the diameter was of 0.013 meters and a mass of 0.25 kilograms. Understanding the main formulas and concepts used in this experiment is crucial before I share my results with you. So let's get into it. First of all, we have Newton's second law of motion. And what does this law say? It says that the force applied on an object is equal to the product of its mass times its acceleration. We know that this formula is also known as a fundamental principle. Now, from the fundamental principle, we can get to the velocity updated formula, which states that the final velocity of my object equals its initial velocity plus the net force divided by the mass multiplied by the change in time. So, why am I sharing this formula with you? Because of the net force. The net force is what is going to carry us through this experiment. Net force is considered as the sum of all the forces acting on my system. And remember, in this experiment, our system is the basketball. Now, the two things that we're going to add to get our net force are the force due to the earth, which can also be called weight, and the drag force. The force due to the earth only has a value in the y component, and it is negative because we're going in the downward direction. And the drag force is proportional to the speed squared. Now, the drag force on the other side goes in the opposite direction of my weight, which means it will have a positive value. Now that you know the main important concepts, we can get through the data. So, first step was analyzing our video. In this image, you can see Tracker, which was the software that we used to analyze our video. And to your right, you can see the main important values that we're going to include into our code to get our model. So first of all, we have the initial frame, which was of 49, our final frame, which was of 67, our change between each frame, which was of 0.033, our final time, which was right before when the ball hit the ground, and our final position. Also, it is important to note that our object is moving in the negative y direction, and the object was at rest, which was when the object was held by the hand. All of these values are crucial because we're going to get into our computer to get our model and be able to compare our results. So once we obtained all the values from Tracker, we just added this to our code to get our computational model. The first thing that we changed was the mass of the ball. Also, as you can see, the position is not exactly 0 because when the axes were evaluated in Tracker, these were not given exactly a 0. However, the values are very small, which can also be considered as 0. We also have delta t, which is the change between each time frame. We have our g, which is our constant, which is very important to calculate our force due to the earth. And we have the value of b, which we're going to use to calculate our drag force. The value of b changes between each type of model. When we did our model without the drag force, the value of b was 0. But when we did the value with the drag force, this value of course changed because it depended on when the final position of our computational model was equal to the final position obtained through our observations. And to your right, we can just see our for loop, which will stop when we get to 0.6 seconds, which was our final time. And we have the values that will be changing for weight, for drag force, and our net force, which there is a negative sign between each of these because remember, the drag force goes in the opposite direction as my weight. Once we obtain all the values from our model and our observations, we created these graphs. So the graph that you see here is the observational model. And as you can see, the object goes in the negative y direction as the time increases. As you can see, there's a huge difference between our lines, except the observational model and the model that includes gravity and drag force are very similar, which means that the analysis done in Tracker was successful. Now, the model with only gravity is very different from the others because this does not apply a realistic situation in which the air force is included, and also because our net force is not equal to zero. What does it mean that our net force was not equal to zero? That means that there was no constant velocity for the computational model without the drag force. In these two graphs, we can see the main difference. The graph to your left shows a constant velocity, whereas your graph to your right does not. The only thing with the graph obtained to your left is that there's a small curve at the beginning because the video was analyzed before the time frame in which the object obtained a constant velocity. However, we can see that after the curve, the line is very constant. In the other case, when we don't have a constant velocity, that means that our change in velocity is not constant and our net force is not equal to zero, because the only force that will be taken into account will be the gravitational force, which would be the force due to the Earth in this case. Now, what if we threw the object but not from rest? This means that our initial velocity would have not been equal to zero. And to test this, I included in our code different values for our initial velocity, and in this case you can see that I just typed 1, 2, 3, and we can immediately see how the computational model changes completely. The velocity of course is not constant, and then we can see a projectile motion. This means that our initial velocity not being zero has a different effect on the motion of our object. Now, to conclude, we have to take some of these key points into account. First of all, the most important thing is that when we do computational modeling, we have to try to make it as realistic as possible. In this case, was just adding the drag force, and we could see how that made a huge difference between our models. Now, in my case, for future experiments, I would take an object that moves a little bit slowly so that I can take more positions when the object went from its rest to its final position. And I would also start the video in a time frame where the object has a more constant velocity so that the computational model for our drag force and gravity is able to show a more constant line. I hope this video was helpful and you were able to understand the motion of a falling object. Thank you.